Hey guys, it's Miss Marflack here. We're going to finish up our last lesson with exact values, and that's going to be day 3. In day 3, we're going to be taking a look at some more coterminal examples. We started this together in the last video, and we're kind of just extending on this and doing more example problems, and then we're going to take a look at some negative angles. Keep in mind that this is the last day of exact values. We've spent 3 days on this topic, and after this lesson, you will have a test review, and then after that lesson you will have a test. So make sure you're paying attention, you're focused, and you're emailing me if you have any questions. Just like we started off the last video, we're going to also start off this video with that quick recall. It's important that we just go over a few things from the past 2 videos because we're going to be working with the same topic, exact values. We've talked about how cosine is the x-coordinate on our unit circle and sine is our y-coordinate on our unit circle. Putting in those x and y coordinates, we were able to see where each trig function was positive and where each trig function was negative. We used the identity that sine over cosine, y over x is equal to tangent. And then we saw in quadrant 1, all trig functions were positive. In quadrant 2, just sine of an angle was positive. In quadrant 3, just tangent of an angle was positive. And in quadrant 4, just cosine of an angle was positive. And then everything else was negative in that quadrant. We use the acronym All Students Take Calculus to kind of help us remember. Also in the last video, we went over how to evaluate quadrantal angles, which I'm putting in here. That's our 90, our 180, our 270, and our 360. We mainly use the 4 coordinate points on the unit circle for that, the 1, 0, the 0, 1, the -1, 0, and the 0, -1. And then we saw that, sine of 270 was just the y-coordinate, -1, and cosine of 180 was just the x-coordinate, which is -1. And then tangent of 0 degrees would be y over x, 0 over 1, which was 0. And then the last thing we need for to make this video together is just our 2 special right triangles. Now, when you're ready to take your assessment, the top of your paper should look like my paper right now. You cannot do any trigonometry without having down these 2 special right triangles. I have them memorized, but even as I'm doing these practice problems, I'm glancing back and forth at this top of the paper here. And then I also have been keeping track of this beautiful orange paper. We're going to be adding some stuff to it today as well, and I'll put this in with your reference sheet along with your unit circle to kind of help you with studying and also on your assessment. We're just going to go over a few practice problems to kind of jog our memory, and the first one we're going to take a look at is from the very first video, and we're going to find the exact value. Now, we laid out this very neat plan for finding the exact value, and it went as follows. First, we solved for the quadrant. Then we asked ourselves, is that trig function positive or negative in that quadrant? We asked ourselves what the reference angle was, and then we evaluated the trig function of that reference angle, and then we made it positive or negative based on the quadrant, and that was our final answer. Taking a look at number 2, we're going to evaluate tangent of 270 degrees. This was from the previous video. When it's a quadrantal angle, we're now using the coordinate points on the unit circle, and we got to keep in mind that tangent is y over x. So since tangent is y over x, we're going to take our y and x coordinate at 270, and that's -1 over 0. And then keeping in mind that we cannot divide by 0, this is undefined. And then there's our answer for number 2, a quadrantal problem. And then we'll just do one more. Let's see here. Switching between papers, we're going to do sine of 315 degrees. Take a look at your unit circle. 315 degrees is in quadrant 4, where cosine is positive, sine is negative, and it's 45 degrees away from the nearest x-axis. And then we do sine of 45 degrees. You could pick any 45 degrees here, and that's going to be opposite over hypotenuse. 1 over square root of 2, we're going to make it negative. But you can't have a radical down there in the denominator. That is not simplified, so we're going to simplify it by multiplying by that denominator there. This process is called rationalizing the denominator, and I'm just multiplying by 1 here. And now when I multiply straight across, I'm no longer left with a radical in the denominator, and there was my answer for number 3. All right, and then also in our last video, Not only did we find the exact value of problems like quadrantals, we started with the coterminals. I only did a few examples, and then we're going to just do a few more here today together. The coterminals I saw in our previous work was a little bit of a struggle, but you do have a calculator. Keep in mind that you are just adding or subtracting 360 degrees. All right, so here we are. We're going to take a look, starting that numbering all over again, and we're going to take a look at cosine of 510 degrees. Okay, so you can see 510 degrees is past 360. So I want to take 510 degrees and I'm going to subtract 360 and I'm going to find a coterminal angle. We're going to borrow from the 5, switch that to 11, we got 5, and we got 150. You could use a calculator for that. And then now cosine of 510 degrees is going to be the exact same value of cosine of 150 degrees. They're the same angle. They share the same initial and terminal side. They're just on different revolutions or rotations. So they're going to have the same coordinate point and the same cosine. Okay, now we can evaluate cosine of 150, and 150 is in quadrant 2 between 90 and 180. Sine is positive in quadrant 2, cosine is negative, and then 150 degrees is 30 degrees away from 180. Then we can use our pretty triangles up here, and we're going to do cosine of 30 degrees, and that's adjacent over hypotenuse, and then we're going to make that answer negative, and then I'm going to box in my answer here. So cosine of 510 degrees and cosine of 150 degrees is equal to negative square root of 3 over 2. Moving on to number 2. We're going to try to evaluate sine of 540 degrees. All right, that's past 360, so let's solve for a coterminal angle there. All right, in our coterminal angle, we're going to subtract 360 degrees. So I have 0 minus 0. I regroup the 5. And the 4 becomes a 14, we got 8, and we got sine of 540 degrees is the exact same as sine of 180 degrees. So I'm able to evaluate that. And then now bells should be kind of going off in your head, beep, 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 that 180 degrees is a quadrantal angle, which means I'm going to be looking at the y-coordinate on my unit circle. And then I could pull out that y-coordinate, and that y-coordinate is 0, and there's my answer. All right, if you don't like constantly having to go back to the very, very big unit circle, what you can do is draw a tiny picture up here. I like to do this a lot, especially with my pre-calc class. When we get ready every day up on the board, I write down our 2 special right triangles, and then I also draw this little picture here. Now this picture does not include every angle. This is just for the quadrantals, and I like to put in those coordinate points 1, 0, 0, 1, negative 1, 0, and 0, negative 1, using the fact that radius of the unit circle is equal to 1. And then we could use that little picture up there. Okay, number 3. We're going to find a coterminal angle and solve for tangent, ooh, this is a big angle, of 1020 degrees. All right, so we're going to take 1020 degrees and we're going to subtract 360 degrees. We have 0 minus 0, 0. I can't do 2 minus 6, so I'm going to borrow from the 10, and then I regroup the 2. We're going to have 6, 6. But 660 degrees is still past 360 degrees. So I'm also going to go again, and I'm going to subtract another revolution using that calculator, checking Miss Marflack's work, making sure she's doing okay, and you can see that this is equal to 300 degrees. So 1020 and 300 degrees are coterminal. So now I can evaluate tangent of 300 degrees by figuring out what quadrant 300 degrees is in. It's in quadrant 4, where cosine is positive, so tangent is negative. And then 300 degrees is 60 degrees away from that x-axis. So we're going to do tangent of 60 degrees and make it negative. Let's do that. Tangent of 60 degrees is going to be opposite over adjacent, and we're going to make that answer negative. And there's my answer for number 3. All right, how many more do I have for you for coterminals? I think that's it. Oh, no, I got one more. One more for coterminals, and here we are, cosine of 420 degrees. All right, so we see 420 degrees is past 360. So we're going to take that 420 degrees and we're going to subtract a revolution and solve for that coterminal. Can't do 2 minus 6, so I'm going to regroup the 4 and regroup the 2 to a 12. And then I subtract, I get 6 here, and then 3 minus 3 is 0, so my answer here is just cosine is 60 degrees. And then 60 degrees is in quadrant 1, where all the trig functions are positive. It's 60 degrees away from that x-axis, and then now cosine of 60 degrees is adjacent over hypotenuse, and we're going to get a positive 1/2 here. All right. Now that's going to be it for our coterminal answers. If you'd like, you can double check with your unit circle. For example, cosine of 150, that should be your x coordinate. Tangent should be your y over x, and then here cosine, that is your x coordinate. Okay, so you can kind of go, if you'd like, go back and double check your answers. All right, now we're going to move on to negatives. We're going to see a little bit of more coterminals. After we do negatives, we're going to do them both together. But for right now, we're going to put the coterminals on hold. All right, so you can title the top of your paper, negatives. All right, now the only difference here with negative angles is that they open up in the opposite direction. So instead of opening up counterclockwise to quadrant 1, our angle starts on our positive x-axis and it opens like downwards to quadrant 4. So I'm going to put that negative theta in here. So then now when we're going in this direction around the circle. This is going to be negative 90 degrees, all right, a right angle. This is going to be negative 180 degrees, a straight line. This is negative 270 degrees, and now this is negative 360 degrees. But here's a really common misconception. The quadrants don't change. So this is still quadrant 1. Okay, but now quadrant 1 is any angles between negative 270 and negative 360. This is still quadrant 2. This is still quadrant 3, and this is still quadrant 4. Another thing to note here is those 4 coordinate points from our tiny little unit circle, they also don't change. So now at negative 90 degrees, you still have the coordinate point from 270. So the only thing that's changing here is how we label our axis, but our quadrants don't change and our points on the unit circle don't change. All right, and then here we are, directions are still the same. Let's jump into some practice problems and we're going to find the exact value. Now you're going to notice here that I'm going to be putting our angle in some parentheses. That's done sometimes when you have a negative, okay? So I'm going to put that angle in parentheses. All right, so here we are. We have negative 120 degrees. So the first thing I'm going to do is the same process that we've been doing earlier. Quadrant, is it positive, negative, reference angle, and then give me the answer. So let's figure out what quadrant this is in. It's negative, so it opens up downwards, and you can see it's between negative 90 and negative 180, so it lies there in quadrant 3. In quadrant 3, tangent is positive, everything else is negative, so sine is negative. And then now negative 120 and 180, all right, they're 60 degrees apart. All right, so that's going to be our reference angle, 60 degrees. And then we're going to do sine of 60 degrees, and we're going to make it negative. So here I am, 60 degrees. Sine would be opposite over hypotenuse, and our answer here is negative square root of 3 over 2. And then there's my answer for a sine of negative 120 degrees. All right, let's take a look at number 2. We're going to evaluate cosine of negative 210 degrees. All right, so 210 degrees, we rotate downwards, we pass negative 90, past negative 180, and then here we are lying in quadrant 2. In quadrant 2, sine is positive, cosine would be negative. And then 210 or negative 210 is 30 degrees away from negative 180. So we're going to do cosine of 30 degrees and make it negative. Cosine of 30 degrees is adjacent over hypotenuse, and it's the same answer as number 1, negative square root of 3 over 2. All right, moving on to number 3 here. We're going to evaluate tangent of negative 330 degrees. All right, so we open up downwards with that negative angle and we rotate past negative 90, past negative 180, past negative 270, and here we are lying in quadrant 1. In quadrant 1, all the trig functions are positive, so tangent's going to be positive, and then we're 30 degrees away from that nearest x-axis, which is negative 360 degrees. So we're going to do tangent of 30 degrees and keep it positive. Tangent of 30 degrees is opposite over adjacent. And we're going to get that 1 over square root of 3, and then there's that radical in the denominator again. We got to get rid of that by rationalizing, and we get square root of 3 over 3. Moving on to number 4, we're going to evaluate sine of negative 270 degrees. All right, bells should be going off 90, 180, 270, 360. That's a quadrantal angle. So I'm looking at my y coordinate on my tiny little unit circle. Negative 270 degrees would be here where 90 degrees is. So I'm going to look at my y value at 90 degrees, and it is 1. And then there's my answer for sine of negative 270 degrees. All right, we're on 5 out of 8, so we're doing pretty good. Cosine of negative 60 degrees. Okay, negative 60 opens downwards and it doesn't get to 90 yet, so it's lying in quadrant 4, where cosine is positive and it's 60 degrees away from 0. So we're going to do cosine of 60 degrees, which is adjacent over hypotenuse, and we get a positive 1/2. Moving on to number 6. We're going to evaluate tangent of negative 90 degrees. Bells are going off. That's a quadrantal angle, so I know that tangent is sine over cosine, or y over x. Negative 90 degrees is the same as 270 degrees. So I'm going to take my y over x, which is negative 1 over 0, and I'm going to write that ratio, negative 1 over 0. And then keeping in mind, it is okay to have 0 in the numerator, but no, it is not okay to have 0 in the denominator. So this answer here is undefined. All right, 2 more to go. Number 7, we're going to evaluate sine of negative 315 degrees. We open up downwards past negative 90, past negative 180, past negative 270, and then here we are lying in quadrant 1. In quadrant 1, all the trig functions are positive, so sine is going to be positive, and then we're 45 degrees away from negative 360. So we're going to do sine of 45 degrees, and that's going to be opposite over hypotenuse, and then you should recognize, just like number 3, that you can't have that radical in the denominator, so we're going to rationalize here, and we get square root of 2 over 2. And then here's the last one for us to kind of sum up these negative angles. That's going to be cosine of negative 180 degrees. All right, bells are going off. That's a quadrantal angle. Cosine's my x-coordinate, and negative 180 is the same exact angle as positive 180. So we're looking at my x-coordinate at positive 180 degrees, and that's going to be negative 1. All right, and then that's going to be it for our negatives. And then now we're just going to do 4 example problems of putting the coterminals and putting the negatives together. So that's what we're going to do now. Coterminals, and negatives together. And then this is the last thing we have to do with exact values. Yay! Number 1, starting the numbering all over again, different color here. Now putting together the 2 things we learned in this video. Sine of negative 690 degrees. Whoa, okay. So I see negative 690 degrees, and I see it's greater than negative 360 degrees. So now we're able to evaluate any angle from negative 360 to positive 360. So I need to add and find a coterminal angle. So I'm going to take negative 690 degrees, and I'm going to add a positive 360 degrees. Use a calculator with this if you're not comfortable with the rules for integers. Okay, but Miss Marflack knows that opposite signs we subtract and take the sign of the number with the biggest absolute value, which is going to be 690 here. So I know I can subtract these and then take the sign of that number. Okay, so I know that sine of negative 690 degrees is the same as sine of negative 330 degrees. So you can either evaluate this like we did just up here, we did tangent of negative 330, or if you'd like, you can add another 360 degrees. And then you're going to get a positive 30 degrees here. So that's kind of like another way to solve for the negatives. You could have added 360, added 360, added 360, okay? But I wanted to help us think in negatives as well, all right? But I just want to show you here that sine of negative 690 and sine of negative 330, and then here's the last one, sine of 30 degrees, they're all equal. So these 3 angles are coterminal. So if you just added 360 in your calculator, you'll see these 3 angles. So you could either use this one or this one to evaluate. I'm going to use this one because we just did this type of problem above, and we know that 30 degrees is in quadrant 1, where sine is positive, reference is 30 degrees, and then we're going to have opposite over hypotenuse, and we're going to have a positive 1/2 here. Positive 1/2. And then that's it for number 1. All right, so find a coterminal angle, either use the negative or the positive one. Number 2, we're going to do tangent of negative 450 degrees. All right, here's the next one. So I want to find a coterminal for negative 450 degrees, which means I'm going to add 360 degrees, which you can do in a calculator, and you're going to get negative 90 degrees. So tangent of negative 450 and tangent of negative 90 are the same thing. Or you can add another 360 degrees in your calculator, and you're going to see that that's also equal to tangent of 270. So whichever one you like. And then there's those Bell's quadrantal angle, y over x, and at 270, our y is negative 1, our x is 0. So we have negative 1 over 0, and that answer is undefined. All right, here are the last 2 examples in this video. Don't go anywhere. Number 3, cosine of negative 510 degrees. All right, so we're going to take negative 510 degrees and we're going to add 360. I know that I can subtract these 2 and take the sign of the bigger number, which is the 510. And when I add 360, I get negative 150. I can evaluate this just like I did above, or I can go ahead and I can add 360 degrees one more time, and in your calculator, you should see that that's cosine of 210 degrees. So all these 3 are equal. So I'm going to use this one down here, cosine of 210 degrees, and I know 210 is in quadrant 3, where tangent is positive. I'm 30 degrees away from that x-axis. We're going to do cosine of 30 degrees, which is adjacent over hypotenuse, and we're going to make it negative. So our answer here is a negative square root of 3 over 2. And then here's the last one for today. We're going to evaluate sine of negative 420 degrees. So we're going to take that negative 420 in your calculator, go ahead and add 360. And when you add 360, you should get negative 60 degrees. So you could do it like we did above and say this is in quadrant 4, where sine is negative, or so on. Or you can add another 360 degrees, and you get sine of 300 degrees, which is also in quadrant 4, where sine is negative, the reference is 60 degrees, and we're going to have opposite over hypotenuse. Yep, opposite over hypotenuse, and we're going to get negative square root of 3 over 2. All right, that is it for today. I love how I say that is it, like we didn't do much, but we did tons of things. So once again, we did a quick recall from the previous videos. We did a little bit more work with evaluating coterminals. Then we did some work with negatives, and then we put coterminal and negative answers together. All right. This is it for exact values. Our next video is going to be a quick, like 15 or 20 minute review, and then you're going to have a test. So email me if you're struggling or if you have any questions.